This is the video for Epic 4 Advanced AI. The previous three videos in Epic 1, the previous three epics. In Epic 1, built and flew an FPV drone. In Epic 2, built and flew a Pixhawk drone, the bigger drone. And in Epic 3, added AI to the Pixhawk drone. So I did all these and demonstrated these all step by step. Now, in this video, we want to talk about advanced AI, or I want to show you what I did. And Epic 4, on July the 4th, I took Epic 4 and 5 and reorganized them into these three epics. And why? There's a lot of reasons why, but in a later video, we'll talk about Epic 6, which are pie in the sky topics. The more and more I thought about it, these topics I don't really think are important. They're too complicated, they're too problematic. It's described basically here. Right now the page I'm on is the wiki organization. And just pie in the sky topics. When I first started out, these topics I thought were the most important. And some of them I thought were the most important. In particular, Siddle and Ross and Hiddle. But now, the more and more I learn, I think they are not. Anyway, this video is about Epic 4, Advanced AI, which is simpler than what it used to be. So our goal, basically, in Advanced AI is to practically use AI in the typical ZiptieAI style copter. And for this, we need three things. We need some kind of simulation to make sure that the program that we write in Python that will tell the copter what to do after the copter has recognized something. Remember, the copter recognizes something in Epic 3, and it does a simple land program. But if you want, you can get into really complicated. You can make the copter fly a certain mission, like where it just flies around on a predetermined path. Or you could make the copter, for example, go after a target. Or you can make a copter come back home. Or there's all kinds of things you could do. If you did that without testing, without simulating, that could be problematic. You could get yourself into trouble. So first of all is doing this simulation. Secondly is then looking at all the programming possibilities you have for telling the copter what to do, what Python APIs you can use. And then finally in this part, these AI, in late 2023, when I first started, I actually first started studying just the AI. I got into copters a little bit later, in late 2023. And these right here, this part right here, contains all my notes that I had when I was studying and trying AI on a computer and on Jetson Nano. So that's what this section is. I apologize for the background noise. That's rain on my tin roof. I hope you can still understand what I'm saying. So that's Epic 4, and I'm here in the wiki organization, and this is Epic 4. Okay, and yeah, I still need to do some reorganization here. I forgot. So now I'm back. One reason why I have organized the wiki, organized the ZiptieAI documentation like this, is that it's easy to redo these videos. I don't try to show you all the directions in the video, because that way I can update the video very often. And so I just updated, I just added this section in the wiki, this advanced AI, software and hardware simulation. And let's click on that. It still shares this same page because changing the page names is a problem in this GitHub wiki. We go here and it shows what I did. Here was my setup. All I used for this was the flight controller. The frame and all is still here, but I pretty much disconnected everything, almost everything. The flight controller, the Ethernet connection, and then the Nano here at the bottom. And this screen is from the Nano. So all you need is the FC and the Nano pretty much. And what this does is, the reason this software and hardware I'm using this is, it's much, much faster than the HIDL, the hardware in the loop. It requires less resources, and it gets the job done of what you need to do for the typical ZiptieAI. And so I tested this, and it put the copter into land, so I think everything is okay. So I created a document that documents in detail what I did. So that is the software and the hardware. And that way you can write these Python programs, you can write these programs and then test them and make sure that it basically, the logic is what it should be before you actually go out in the field and try it. And a two-dimensional output like this is better than a three-dimensional. It's simpler. It's all you need. You have your right here. You have your altitude and everything. So I think it's good. And after that, it talks about, this wiki talks about the firmware APIs. And so here's a great diagram that shows how you can actually tell the flight control unit, you can actually control the flight control unit to make it do something, to make it go somewhere, to make it land, to make it, I don't know, fly around in circles, whatever you want. This is from drone programming libraries from Intelligent Quads. This is their diagram. But I added in here what I think is missing. There's the main concept here is there's a Mavlink API. I call it a server. And all you need to do is send over any kind of connection, Ethernet or whatever the connection is, these Mavlink commands. And a flight control unit will automatically pick them up and do what you're commanding. And Mavlink, to make those commands, there's a program called PyMavlink, which is Python Mavlink. It's the simplest tool you can use. And you write Python programs, and then PyMavlink takes what you wrote and converts it into Mavlink and sends it. But there's also MavROS, and ROS is a pie in the sky topic, so forget about that. But there's Drone Kit, which I think is basically a product that's been dead for 4 or 5 years. And then there's Mav SDK. But there's also Q Ground Control and Mission Planner are basically doing the same thing. You go to Q Ground Control, you use all of these visual tools, but in the end what they're doing is they're sending, as I understand, Mavlink commands to the Mavlink API server. So, yeah, and so that's what he says here. You can also use as a programming interface these. Okay. So let's go here. Yeah, there's several. Yeah, right now, all I have is a document about Mavlink and an API's overview document. I didn't spend a lot of time in this for now because the previous examples were all, we just need a simple Python program to tell the copter to do something simple, like land a copter. But in the future, I will try to add a lot more about Mav SDK, PyMavLink, and maybe also go in and analyze a little bit what QGC does, Q ground control. The reason this might be important is for a long time I was having problems with getting PyMavLink to work with this API server. I couldn't get it to work, and days I was working on this. But the QGC would always work with it, so I knew there was some difference between them. So I kept searching and searching, and I finally found a forum where somebody was talking about QGC. I think this is what it was. QGC always sends a heartbeat first, a heartbeat message in Mavlink. This is Mavlink API server. And the examples in the official documentation for PyMavLink never showed, it just showed making a connection, but never sending the heartbeat first. And that is what the problem was. And I talked about this in a forum, and it's an obvious, to me, major mistake in the documentation. But I don't think they'll update the documentation. So, and that's typical PX4 ArduPilot documentation. It's out of date, it's missing things, and that's why I do things the way I do in ZiptieAI. But if you follow my example, I show in the code examples what that was, sending the heartbeat first. So my objective here in doing all this is getting started with no hitting the wall, no rabbit holes. And it's impossible to do that without something like ZiptieAI because the documentation is got so many problems. In PX4 and ArduPilot, there's so many things missing, and they'll never update it. And they never reorganize their documentation, which is chaos. So, and then a final thing here is going to be the AI algorithms. And that's what I started doing last year in 2023. And here's a small diagram showing that, forget the ROS stuff. I was thinking ROS was going to be important. Forget that. I need to change this diagram. But you've got a C++ or a Python program, Python in our situation. And then you get input from a camera. Okay. Now, originally, the camera was going to go through a ROS node, but forget that. It's just going to go straight here. The camera goes straight to the companion computer. Then the companion computer, the Nano, does the AI and recognizes things. And then this Python program, it takes control, or it sends control messages to the flight controller. So in this part right here, the focus is on these programs, these Python programs. And again, I use PyMavLink, but you could also use Mav SDK and DroneKit. I think DroneKit works, but I don't know if you'd want to use it. And go into here, there's into the Gdrive. There's quite a few documents, like here's a 150 megabyte document, a lot of screenshots. But I spent a lot of time on this. Originally, I wanted to focus just on AI. That was in the fall of 2023. I think I was in Ukraine. Then I really got interested in AI drones, intelligent drones. And after I did the intelligent drones software simulation series, which took about a month and a half. And so then I started exploring AI with the drones. I thought the drones would be simple. They're not. So I've spent about 5-6 months learning all this stuff about the drones, reorganizing the wiki. using AI on the drone is what really interests me. And there's way too much material here, but I've explored a lot of topics, and my goal eventually is to have examples for just running on a Ubuntu or Pi or the Jetson Nano. Also on the STM hardware, which is what the FC is based on. But this is a work in progress. Now that I've gotten this far, I'm ready to start focusing on this. I need to pick out the few routines that are of real interest and then document them in more detail. And that's about it for this video about Epic 4. So I'd just like to add, I went back through and changed this diagram. I apologize for the quality of the diagram. I originally did these in Lucid, and I didn't want to pay for a Lucid license and I have too many diagrams, so I just edited this in this Microsoft Paint. So anyway, this shows now, what we're doing here in this AI. There's no ROS, there's no complicated pie in the sky stuff. It's just basically getting things done. The camera sends the output to the companion computer, which is in our case going to be the Nano. And the AI routines on the GPU, they're the brains that figure out what is there, they recognize something. Then you come over and you have a Python program that through PyMavLink sends a Mavlink commands to the flight controller, and that's how it works. And that sums up advanced AI here.